I do all the marking. I do all marking nearly 400 scripts every week, and I scan all of them, and I email every one of you. So it's a lot of work for me. So I would really appreciate if you could, I know the deadline is 3 p.m., but if you could hand it in to me well in advance, that would make my work easier. You know what I'm saying? So don't wait till 3 p.m. to hand in your work. Try to hand it in, say, by 2 p.m. or even 1 p.m. on Monday. So that will give me plenty of time to do all the work. All right? You know what I'm saying, okay? All right. Now, before I start, I want to summarize what we did on Monday this week, right? I want to summarize what we did. On Monday, we talked about summary statistics, right? So when you have a data set, x1 to xn, the first thing I talked about on Monday is order statistics. Order statistics is basically the arrangement of the data from the smallest to the largest value. So x sub in brackets 1 is the smallest data point. X sub in brackets n is the largest data point. All right? Then I talked about the mean, which is the average. I'm sure all of you know what a mean is. And then I talked about the median, which is defined differently depending on whether the sample size is an odd number or an even number, right? All right. Then I talked about quantile. Quantile is denoted by Q or P, and P is a number between 0 and 1. So for example, when P is half, Q of half is the same as the median. All right? So, and it's defined by this formula here, where R prime is the integer part of P times n plus 1. And so what you have here in the middle is P times n plus 1 minus R prime. And if it happens that R prime is 0, then Q of P is the smallest data point. If it happens that the R prime is n, then the quantile is the largest data point. Okay, and this notation here, the square brackets, means the integer part. So for example, the integer part of 1.8 is 1, the integer part of 2.1 is 2, and so on. Okay. Then I talked about, I'm just summarizing what we did on Monday. Then I talked about Q1. Q1 is the first quantile, is known as the first quartile, is Q at 0.25. In other words, if you arrange the data from the smallest to the largest, is quarter of the way from the smallest to the largest, right? And the third quartile is Q at 0.75. In other words, if you arrange the data from the smallest to the largest, then it is 3/4 of the way from the smallest to the largest, right? And the interquartile range is the difference between Q3 and Q1. And range is the difference between the smallest and the largest data points, okay? Then I also talked about variance. Variance is defined by this, yeah, and it can be simplified to this formula here, yeah. I mean, this is stuff you did in quiz 1, you may recall, yeah. And then I talked about standard deviation. Standard deviation is simply the square root of the variance, right? Okay. And then I did an example. I'm not going to go through that. Then I did one example. This is that example. This is that example. And then I showed you what a box plot is. This is known as the box plot. And basically what it shows you is it depicts, is a graphical summary of the measures that we talked about so far. So the middle line is the median. This line here is the first quartile, or Q1, and this quartile here is the third quartile, or Q3. And this line here at the bottom, this line at the bottom is 1.5 IQR from the bottom line. So the distance, so let me write again here. The distance from this to this is 1.5 IQR. Okay? And similarly, the distance from this to this is 1.5 IQR. Right? Okay, so any data point that goes below this line or any data points that goes above this line are known as outliers. Right? And is that clear, guys? And in R, I know next week we will have a computer lab session, and we will learn how to draw box plots, histograms, and so on. So in R, the way to draw a box plot is using this command, box plot in brackets x. X is the variable name, right? And then I talked about histogram. This is a histogram. It gives you a graphical summary of the distribution of the data. So here the data is on the lifetime of battery. So it shows that the density of the lifetime has this shape, right? And this is the command in R for producing it. And then I showed you there are three types of shape that you can get in a histogram. One is a symmetric, one is skewed to the left, like this, or skewed to the right, like this, okay? And finally, I talked about bar plot is easy. You know, these are kind of things you see in the TV all the time. I mean, even a kid would know what a bar plot is, right? So, and this thing, I forgot to show you this last time. This kind of shows you the quantile. So the quantile, if you draw, this is the line here, the curve that is drawn here is the CDF. So this is the curve of a CDF, right? Now a quantile is basically the inverse map of a CDF. So for example, if P is this, if P takes this value here, right? Q of P is the corresponding value on the x-axis, right? You follow what I'm saying? So if P is, say, half, so this, suppose this is 0.5, right? Then Q at half will be what you get over here. So this point here will be Q at half. You follow what I'm saying? So if you want to visualize what a quantile is, or Q of P is, all you have to do is to draw the CDF of the distribution, like we did here, and then choose the value for P along the vertical axis, and project them down to the horizontal axis, and what you get in the horizontal axis is the Q of P, right? So for different P's, you can get the corresponding Q of P, right? All right. Now, before I go to the next topic, I just did one example on Monday this week. So let me do just example 2. I know, because some people they asked me to do an example, right? Can you see this from the back, guys? Yes? Oh, by the way, Happy Chinese New Year. I hope you guys had a good time. Yeah. Okay. Suppose suppose you have the data 0, 5, 1, 6. All right? So we have n is 4. The order statistics of the data is 0, 1, 5, and 6. So this is x. All right? So these are the 4 order statistics, right? So the mean, sorry, let me, the mean is x bar, so it's the average of the data points, so it's going to be 0 plus 1 plus 5 plus 6 divided by 4 is 3. Okay, so the mean is 3. The median is going to be the middle, right, because here we have even number of data points, right? What you do is you take the middle 2 points. The middle 2 points are 1 and 5, right? And you take the average of them. So the median will be also 3, yeah, okay. And in fact, you can check this using the formula, the other formula I gave you. Let me go back to that. You see, this is the formula I gave you on Monday, guys. You remember this, right? The median is the same as Q at half, right? So Q at half is R prime will be what? R prime will be P is half 5 over 2, which is 2, right? Okay, so Q at half will be x sub 2 in brackets, right? 5 over 2 minus 2 x sub 3 x sub 2. You see what I'm doing here? I'm just applying this formula here I gave you on Monday, right? Right, with p equal to half and n equal to 4, right? Okay, so if you do that, x sub 2 is 1 plus this guy here is half. Then you have x sub 3 is 5 minus 1. So you get the answer 3. You see? So the answer is the same. So you can do it either way. You can do the median like this, or use this formula with p equal to half. You should get the same answer, right? You follow what I'm saying? Yeah. Yeah. Okay. Now. Let me put this over here. This is example 2. Right. The next thing is first quartile. First quartile is Q at 0.25. Okay. So your P is what? P is 0.25, and your N. So it's, let me write it down. So your P is 0.25, and your N is 4. So R prime will be 5 divided by 4, which is 1. Okay, so R prime is 1. Okay, so put this in a box. Okay, then you get, using the formula that I mentioned before, I mean this formula here, if you use this formula, you get x at 1 okay, right? X at 1 is 0. This is a quarter. 1 minus 0. So you get a quarter. So Q1 is a quarter. Is that clear to you, all of you? I mean, it's a simple application of the formula that I mentioned to you on Monday. Yeah? All right. The third quartile, we are looking at Q3, which is Q at 0.75. All right. So your P is 0.75, your N is 4, so your R prime is going to be it's going to be 15 divided by 4, the integer part of that. So this will be 3, right? So the integer part of this is 3, right? Okay, and so using the formula that I gave you on Monday, guys, you get, this is x sub 3 plus all right, you will get this, right? X sub 3 is 5. This guy here is 3 over 4. X sub 4 is 6 minus 5. All right? Okay, so this is going to be 5.75. Is that clear? Right? So the third quartile is 5.75. And the first quartile is a quarter. Okay? All right, let me put this over here. Right, then the next mesh summary statistic is the IQR. The IQR is the difference between Q3 and Q1, right? So which is 5.75 minus a quarter, so which is 5.5. Okay? You guys okay? The next one is the range. The range is the difference between the largest and the smallest observations. So it is x sub 4 minus x sub 1, which is 6 minus 0, which is 6, right? And the variance is 1 over n, which is 4 times sum from 1 to 4 of xi minus x bar. X bar we already worked out is 3. This is the variance, right? If you have a calculator, you can do this. So this will be 1 over 4. The first term is 0 minus 3 squared. So this is the formula for the variance, right? And finally, the standard deviation is the square root of the, I mean, you can work this out easily. So it's going to be quarter 9 plus 4 plus 4 plus 9. All right? So it's going to be 18 plus 8 is 26 divided by 4, which is 13 divided by 2, which is 6.5. Right? That's the, correct me if I'm wrong. Like sometimes I can't even do simple arithmetic correctly. So, all right, and finally the standard deviation is simply the square root of 6.5. Okay. All right, guys, are you happy with this example? Yes? Right. So let me now move on to the next topic. I mean, next week in the computer lab session, you will practice how to compute summary statistics. You will practice how to draw histograms, box plots, bar plots, and so on, right? So those are kind of stuff we'll talk about Monday and today, right? All right, the next, now you may remember last week that we talked about continuous data and discrete data, right? Before, just an announcement before that. About the example classes, I mean, I want to make clear that it is really important that you do come to the tutorials. There are 5 tutorials every week. You must come to one of them. I mean, you can choose the one you want to come. You don't need to follow what is in your timetable, right? You can choose the one you want to come, but it's really important that you do come to at least one of them, right? I will take attendance, but two of the 5 tutorials are done by my colleague, Tim Wade. It seems that he doesn't take attendance, or he doesn't podcast, but he doesn't podcast the tutorials. But the three tutorials I go to I will take attendance, and I will also podcast the tutorials, as well as do the scan notes for the tutorials. I will post them online. So if you can come to my tutorials, please do so, right? So it's really important. And today, Thursday, we have 2 tutorials. So if you haven't been to the tutorials this week, please come to one of the 2 tutorials today, right? Okay? All right. Now, back to class, right? Now, I'm sure you heard about this. I'm sure you guys heard about the normal distribution, right? The normal distribution is the most popular model for continuous data. The normal distribution is also known as the Gaussian distribution because it was invented by Friedrich Gauss, the German mathematician, right? Okay, so it's also known as the Gaussian distribution, especially in the engineering literature. They prefer to call it a Gaussian distribution, whereas we mathematicians and statisticians we use the word normal distribution. right? Okay. I'm sure suppose x has a random variable x has the normal distribution, right? Its PDF the PDF of x can be written as follows. Right? This is I'm sure all of you know this. This is the formula for the PDF of the normal distribution, where the domain is from minus to plus infinity. There are two parameters, mu. Mu also takes values from minus to plus infinity. Sigma takes positive values only, right? Mu is known as the mean parameter. This is known as the mean parameter or the mean parameter. And sigma is known as the standard deviation parameter. Right? SD stands for standard deviation, as you know. Right? And if a variable has a normal distribution with this PDF, we write in notation, we write x tilde normally distributed with parameters mu and sigma squared. So this is the notation I shall use. This is the notation I shall use to denote a random variable that has a normal distribution with parameters mu and sigma, right? Okay, guys. Right. Now the next thing is the CDF. The CDF of x, remember CDF is the cumulative distribution function. The CDF of x, when x has a normal distribution, can be written in this form. Right, where phi, the Greek letter capital Phi denotes the CDF of n01. In other words, a normal distribution with mean 0 and variance equal to, or standard deviation equal to 1, right? I will talk about this phi. There are tables for computing phi. I will talk about it later if I have time, right? Okay, now in R, right, if you're using R, the commands for computing the PDF of a normal distribution the PDF of the normal distribution can be computed by the following command: p norm x mean equal to whatever the value. So for example, say 0, right? SD equal to 1. So this command will compute the D, not P, D. I'm sorry. I'm sleeping today. So D norm in brackets X. X is the values at which you want to compute the PDF. Mean is the mean parameter, which is mu, equal to 0. SD is the standard deviation parameter, which is sigma, equal to 1, right? The CDF right? The CDF can be computed by this command P now. So D for the density, P for the CDF, right? Remember that all the time. D for density, P for the CDF, right? Then the rest are the same, okay? All right, guys, are you with me so far? All right, the next one, I need to give some properties, right? I need to give some properties of the normal distribution, right? One, the expectation of x, right? So if x is a normal distribution with parameter sigma squared, right? The expectation of x is mu, right? Number two, the variance of x is sigma squared, right? Number three, the standard deviation of x is sigma, all right? Number four, ax plus b, where a and b are constants. If a and b are constants, right, then ax plus b will have the following distribution. Right? So this is known as the property that if something is normally distributed, any linear combination of it, of this form, is also normally distributed, right? That's what this says, right? So in particular, you should take A to be 1 over sigma, right? Yeah? And you should take B to be minus mu over sigma, right? Then you will have a normal distribution with A is 1 over sigma times mu minus mu over sigma, right? Comma, A squared is 1 over sigma squared times sigma squared. You see, I'm using property 4. All right, if you take A to be 1 over sigma, B to be minus mu over sigma, then according to this property, you will get this distribution. Now, what you have here, this simplifies to 0, and this simplifies to 1. Right? So you have by using this transformation, right? If x has this distribution, this transformation produces a distribution that has mean 0 and standard deviation equal to 1, right? And this is known as the standard normal random variable, right? I'm sure you heard about it before, right? Okay. All right, guys. Any questions so far, guys? All right. Okay. Now, a couple of more properties. Further. Right. I just want to give two more properties which are a little bit more advanced than the ones I discussed so far. Right. The first one is the following. Shh, listen, please. All right, this property says the following, that if you have two independent normal random variables, then their linear combination is also a normal random variable. Right? Okay, and the next one, number 2, is the following. So here you have not just 2, but you have p independent normal random variables, right? Then right? So what this says is that if you have p is an integer, it can be 2, 3, 100, million. If you have p independent normal random variables, then their linear combination is also a normal random variable, right? I hope you can read my writing, guys. So all of these are i's. This is an I. This is an I. All of these are i's, okay? Okay. All right, guys. All right, the next thing I want to talk about is now in the normal distribution there are two parameters, mu and sigma, right? Now how do we estimate them, right? So Okay, suppose you have a random sample. I'm sure you know, you should know what I explained to you last week, what random sample means. So when you go to year 2, when you guys go to year 2 and the lecturer asks you what a random sample is, you should know. Because as I said, I've been teaching year 2 courses and a lot of people don't know what it means, right? Now suppose you have a random sample from a normal distribution. There are 2 parameters that are unknown, the mu and the sigma. So I think I explained this to you last week. The hat is used to denote an estimator of a parameter. So in this case, mu is a parameter, mu hat is an estimator, right? So mu hat is the sample mean, right? And sigma hat is the all of these are i's, okay, don't. Sigma hat is the sample standard deviation, right? So this is the sample mean and this is the right, and this is the all right, so the mu can be estimated by the sample mean and the sigma can be estimated by the sample standard deviation. I mean, you may wonder where these come about, but I mean, you will find, when you go into year 2, you will find out the theory behind this, how these formulas came about. I mean, I cannot teach you now because I'll be teaching you too much, but so you find out about this when you go to year 2. But for this year, you just need to remember these formulas, right? You just need to know these formulas and how to use them. Okay? Right. Now, I want to do some examples now, right? Starting with example 1. Suppose X has a normal distribution with parameters 1 and 4, right? And we want to compute the probability, say, x is less than 2. Now, how do we go about this? To compute a probability that x is less than 2, given the first thing you must do, guys, is to standardize the x. Now, remember, how do you standardize? I just explained to you a minute ago. If you go back to a couple of slides, this is the process of standardization, right? From x to the standard normal variable. So what you do is you subtract the mean, which is 1, right? And divide by the sigma, which is 2. Right, that's what I've done. X minus mu divided by sigma, right? And you do that both sides. Right? So what you get, because of this property here, guys, this one will have the standard normal distribution, and this guy here is 0.5, right? And this is phi, at 0.5. Remember, I told you ages ago, that is, you should go back to the first slide, the couple of slides I showed you. Phi is the CDF of the standard normal distribution, right? Okay, so this probability here is simply phi at 0.5. Now to read this value, when you go to the exam, you will be given a table like this. What this table gives you, I don't know whether you can see this, guys. Can you see it or not? And now, maybe better now. You'll be given a table like this, which contains values of phi. So for example, if you want to read 0.5, all you have to do is you go along this column here. This is 0.5, yeah, and read the first number, which is 0.6915. So this guy here is 0.6915. Is that clear or not? Come on, guys. And can you talk back to me? Yeah. You have any questions on this? Yes. The first number is because you want 0.50. You don't want 0.51. You understand? No, you don't? Sorry. You have, I mean, this corresponds to 0.5, and this corresponds to 0.51. This corresponds to 0.52, and so on. Right? Okay? So that's why I picked this number, guys, because we want to rate 0. Shh! Don't leave yet, guys. Come on, are you guys not having fun? No. Come on. You still have, I mean, okay. Right. So this is example 1, okay? Now let me do another example. You've got 1 minute left, so don't worry. Right. Now, suppose we want to compute, say, the probability that x is greater than 3. Shh. Now, the first thing you should do is to convert this to standard normal, right? So you subtract 1, divide by 2, subtract 1, divide by 2, right? So you get the probability that a normal variable is greater than 1, right? Which, now, because we can only read CDF, you need to convert this into a CDF by using the complement rule, right? So this is the probability that a normal variable is less than or equal to 1 minus this probability, and this is phi at 1. Now, if you go back to the table, guys, this is the table. Now, where is 1? This is 1, right? So we want to read 1.0, which is this number here, right? So this is 1 minus 0.8413. That's the answer. It's easy, guys. All right? Or is it not? All right, finally, if you're done quiz 2, could you please hand it to me now? Because... Thank you, sir. Thank you. Thank you, man. How are you? Thank you. Thank you. applies to the normal PDF. Is that your question, ma'am? I don't understand. Is that what you're asking? Yeah, I mean, if you want, so, I mean, just, I'm not really supposed to help with quiz 2.
Yeah,
I mean,
I
I can only give you